Alien Beauties YouTube channel subscribers and viewers. I think humans will reach Mars, and I would like to see it happen in my lifetime. Mars Mission 2020. Mars 2020 Perseverance rover. The Mars 2020 Perseverance rover mission is part of NASA's Mars exploration program, a long-term effort of robotic exploration of the Red Planet. The mission addresses high-priority science goals for Mars exploration, including key questions about the potential for life on Mars. Perseverance takes the next step by not only seeking signs of habitable conditions on Mars in the ancient past, but also searching for signs of past microbial life itself. The rover introduces a drill that can collect core samples of the most promising rocks and soils and set them aside in a cache on the surface of Mars. A future mission could potentially return these samples to Earth. That would help scientists study the samples in laboratories with special room-sized equipment that would be too large to take to Mars. The mission also provides opportunities to gather knowledge and demonstrate technologies that address the challenges of future human expeditions to Mars. These include testing a method for producing oxygen from the Martian atmosphere, identifying other resources, such as subsurface water, improving landing techniques, and characterizing weather, dust, and other potential environmental conditions that could affect future astronauts living and working on Mars. Perseverance was timed for a launch opportunity between July 30th and August 15th, 2020, when Earth and Mars were in good positions relative to each other for landing on Mars. That is, it took less power to travel to Mars at that time, compared to other times when Earth and Mars are in different positions in their orbits. To keep mission costs and risks as low as possible, the Mars 2020 design is based on NASA's successful Mars Science Laboratory mission architecture, including its Curiosity rover and proven landing system.
Mars 2020 Technology, Heritage and Innovation. Technologies for entry, descent, and landing. The mission uses technological innovations already demonstrated successfully, especially for entry, descent, and landing, EDL. Like NASA's Curiosity rover, the Mars 2020 spacecraft uses a guided entry, descent, and landing system. The landing system on Mars 2020 mission includes a parachute, descent vehicle, and an approach called a crane maneuver for lowering the rover on a tether to the surface during the final seconds before landing. This type of landing system provides the ability to land a very large, heavy rover on the surface of Mars in a more precise landing area than was possible before Curiosity's landing. Mars 2020 takes things one step further. It adds new entry, descent, and landing, EDL, technologies, such as terrain relative navigation, TRN. This sophisticated navigation system allows the rover to detect and avoid hazardous terrain by diverting around it during its descent through the Martian atmosphere. A microphone allows engineers to analyze entry, descent, and landing. It might also capture sounds of the rover at work, which would provide engineers with clues about the rover's health and operations, and would be a treat to hear. Technologies for surface operations. The Perseverance rover design minimizes costs and risks because it is largely based on the engineering design for the previous Curiosity rover. The Perseverance long-range mobility system allows it to travel on the surface of Mars over 3 to 12 miles, 5 to 20 kilometers. Improvements on Perseverance include a new, more capable wheel design. And for the first time, the rover carries a drill for coring samples from Martian rocks and soil. It gathers and stores the cores in tubes on the Martian surface, using depot caching. Caching demonstrates a new rover capability of gathering, storing, and preserving samples. This could potentially pave the way for future missions to retrieve the samples and ferry them to Earth for intensive laboratory analysis. Perseverance tests a technology for extracting oxygen from the Martian atmosphere, which is 96% carbon dioxide. This demonstration helps mission planners test ways of using Mars' natural resources to support human explorers and improve designs for life support, transportation, and other important systems for living and working on Mars. The rover also monitors weather and dust in the Martian atmosphere. Such studies are important for understanding daily and seasonal changes on Mars, and will help future human explorers better predict Martian weather. Thank you for watching.
We're at altitude of 1 kilometer descending. Standing by for sky crane. Sky crane is started.
Signal to us, you remain strong.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us.
Got thumbnail.